standard HDMI cables, they have this dirty little secret.
Oh, yeah.
They give up after, what, 50 feet or so, you get snow or signal drops or just nothing.
50 feet if you're lucky, yeah. And that's where physics, just gets in the way. Copper wire has resistance.
Exactly. But what if you need to send a perfect, uncompressed signal, not just across a big room, but across a campus or a small town?
Right.
So today, we're looking at a piece of hardware that seems to just ignore that problem completely. We're doing a deep dive into the PureLink HOF-TIII-RX. Now, on paper, it looks like a normal little black box, but the spec sheet, it claims things that honestly look like typos.
And we should be clear, this is not something you're going to find at a big box store. This is professional-grade infrastructure.
Absolutely. So let's just start with the headline spec.
Okay,
the distance, I'm used to extenders that could do maybe 300 feet. This documentation says 33,000 feet.
Which is, what, 10 kilometers?
Or 10 kilometers.
Yes.
6 miles.
It's a massive jump. And really, the only way to move data that far without it degrading into noise is light.
So fiber optics.
Exactly. The HOF-TIII-RX uses fiber optics. Specifically, it uses these little things called SFP plus modules.
Okay, so what's the difference between this and, the optical cable I might plug my soundbar in with?
It's all about the type of fiber inside. This device ships with modules for what's called single-mode fiber.
Single mode?
Yeah, imagine a glass tube so incredibly thin that light can only travel in a straight line, right down the very center.
So there's no bouncing around inside the cable?
Almost none, which means the signal stays incredibly strong for miles and miles.
Yeah, that's different from multi-mode fiber.
Right. Multi-mode has a wider core, so the light, it does bounce around inside, which creates signal loss over distance. The spec sheet says this unit is compatible with multi-mode, but that'll cap you at around 300 meters.
So if you want that full 6-mile run, you have to go single mode.
Yeah.
Okay, but usually when you send video that far, you have to crush it, right? Compress the file, you lose detail.
Well, that's the trade-off we always expect, isn't it? Bandwidth versus distance. But this spec sheet, it lists 4K60 4.4.4.
And it's that last part, the 4.4.4, that's the jargon that always trips people up. Why is that such a big deal?
It's all about color fidelity. To save space, most streaming video, most signals, they throw away about half of the color information. It's a trick called chroma subsampling.
And most of the time, your eyes don't really notice it in a movie or something.
In a movie, probably not. But what if you're looking at fine text on a screen? A complex spreadsheet or maybe a medical x-ray?
Then the text looks fuzzy, the edges bleed.
Correct. So 4.4.4 means zero color compression. Every single pixel keeps all of its original color data. This device is pushing that full, uncompressed 18 gigabit per second stream over 6 miles.
So if you're a radiologist, you're seeing the absolute, the exact scan. If you're a video editor, you're seeing the raw footage.
And hearing it too. It supports the big audio formats, Dolby True HD, DTS HD Master Audio. It's basically a transparent pipe.
But I see a practical problem. If my computer is in a secure server room and I'm standing at a display 6 miles away, how do I even pause the video? My mouse isn't going to work.
That's a great question. And that's where the control features come into play. They included bidirectional RS-232 and IR.
Bidirectional, so the cable works both ways.
Yeah, that's it. It's sending that massive video file to you, but it's also got this little return lane for control signals to go back. So you can use a remote at your screen, and the command travels 6 miles back to the source instantly.
Wow. So it completely decouples the user from the machine.
It really does.
I also saw another acronym on the sheet, TAA compliant. Is that just, regulatory fluff, or does that actually matter?
Oh, it matters a lot if you want to sell to the government. It's the Trade Agreements Act.
Right.
It basically just certifies the supply chain for U.S. government contracts.
I see.
And when you put that together with the build quality, it's powder-coated steel, not cheap plastic. And the price, which is around $860, you start to see exactly who this is for.
This is for mission-critical setups.
Military hospitals, huge corporate campuses.
Yeah.
Places where buffering or pixelation isn't just an annoyance, it's a critical failure.
It totally reframes how you think about designing a space.
Yeah.
We always have to put the computer near the person. With this, the computer could be in the next building over. Or the next town over.
It just removes distance as a constraint.
So before we finish up, I just want to leave you with this one thought on the logistics of it all. I've talked about the tech, how to send video 10 kilometers. But just think about the physical reality of laying a 6-mile run of fiber.
Oh, yeah. You're not just an AV tech then.
No. You're dealing with City infrastructure, permits, digging. So what kind of content, what kind of information is so valuable that you'd justify digging a trench across the city just to keep it off the public internet?
Now that is the billion-dollar question.
Thanks for listening to this deep dive. Stay curious.